Okay, so in this lesson we're going to review a little bit of Pythagorean theorem and some old hippie called another hippie tripping on acid trig. Or maybe you like SOHCAHTOA. I'm not so sure that works for me, but whatever works for you on those mnemonics. And I have labeled this picture so that you can see that A, B, and C, alpha, beta, and gamma relate to the sides of a right triangle. I put B on the bottom because I thought maybe bottom and base would help you to know that the horizontal line would be B and the vertical line would be A. But those two actually are kind of interchangeable in some respects. But if we don't all do it the same way, then we'll end up with different answers. And so that's why I thought that might be important in labeling your pictures to all be consistent. The answers on the list will always look the same no matter what you do. And then, of course, B is across from beta, alpha is across from A, and C is across from gamma. So when I look at my list of the information over here, I see I'm only missing one side. So when you're missing one side, you can use Pythagorean theorem to find the one side that's missing. So 5 squared plus 12 squared equals C squared. 25 plus 144 is 169. The square root of 169 is 13. So now I know that this side is 13. Now I have one angle in this picture given because this whole lesson is about right triangles. So always gamma is going to be a 90-degree angle in this lesson because the right angle is across from C and gamma stands for C in our Greek alphabet. So we have one angle, but we have to get the other two. So to begin with, I always focus on alpha first because alpha is the one down that's parallel to the horizontal, it being an angle of elevation opening up. And so I think it's important to label your picture based on that angle and not label it based on beta up in the sky over here. So alpha is across from A, so A would be what we call our opposite side. And B is the adjacent side, and C is our hypotenuse of our right triangle because it's the longest. So you want to label opposite, adjacent, hypotenuse from the angle of alpha. Now, we're trying to find alpha first. So in this problem, if I label my picture A equals 5 and B equals 12, then I see that the original numbers, and you always use the original numbers to get everything, because what if you calculated C incorrectly? You would be able to catch that because the math wouldn't work. So I'm going back and realizing that alpha and beta, A and B, are opposite and adjacent. Now when you talk about the trig, it's some old hippie called another hippie tripping on acid is our mnemonic. So opposite and adjacent is tangent. So tangent of alpha equals opposite over adjacent, which is 5 over 12. Now, in this particular problem, I don't have an angle. So to get that angle, I have to inverse the trig. Because to get rid of tangent, you have to inverse trig both sides. That way, tangent and inverse tangent cancel out. Now, on the calculator, you need to go to your mode button, and you need to turn on degrees, because this whole lesson is about degrees, not radians. This whole unit is about degrees, and that is important during the state testing to turn that on and off also in case a problem is in radians one time and in degrees the next time. Now, we need to type inverse tangent, so that's second tangent, 5 divided by 12, parentheses, enter. And of course it comes out a terrible decimal, but this is degrees. So we need to think about what's the appropriate number of units that we should give, decimal places should we give for the units that we're talking about. Now degrees is measured with a protractor, and when you look at a protractor only has whole numbers on it. It goes 1 degree, 2 degree, 3 degrees. So we should round this off to a whole number to represent our degrees. So that would be 22.6. Excuse me, it rounds off to 23. Because 23, 6 would make the 22 go up. So that's why you want to look at the 22.6 and decide, what does that 6 do? It makes it go up to 23. Now, if you want to be sure that you're on the right track with this, then one of the things that you might would do is use one of the other trig functions to find b, or label your picture from beta otherwise. You could do that as well. But if you want to keep with the labeling you have, you'll have to use another trig function. And that's why A, B, and C cannot be anything but whole numbers or radicals. Do not be writing any decimals down in case it comes out to be a number you can't square root. It has to be treed and be exact on A, B, and C. So when I look at it now, I know that in order to find beta, I'm obviously going to have to work with a different corner. So I could use some of the other trig to work with it and label it with the different words. For example, I'll go through and label it from a beta corner situation. Since I already know this is C, beta is opposite B and adjacent to this one and hypotenuse to this one. So just to prove to you that it doesn't matter which trig function I use, once I have all three sides, let me show you how that works from the perspective of side. Sine of beta is equal to, what's across from beta is 12, opposite, and hypotenuse is 13. So I could inverse 12 over 13 and have that answer. So let's do that. Inverse sine 12 over 13. And that comes out 67.3, so that would not round up, and that would just be 67. Now, if you've done this correctly, these two acute angles should add up to 90. And sometimes there's a little round off there, and they might not round off to 90. The other thing that you could have done for this problem, and I'll just mention this, is if you don't want to change your corner at all, and if you don't want to, let me phrase that. If you don't want to use the number 13, you could say that this is opposite and adjacent to beta, and do tangent of beta is equal to 12 over 5, because those two numbers have the same relationship with opposite and adjacent from beta. It's just the reverse. So you've got lots of options, but you have to relabel your picture if you're going to do it from a different corner. Now, some students say, well, I'm just going to cheat and subtract, and then when they miss one, they don't catch their error. So keep that in mind, that you really want to use two different trig functions in terms of one that helps you to find alpha, label the picture, relabel the picture to find a different one for beta, but you can use any of them that you want. So a lot of times I choose to use one that's based on similar trig. Like this one, I could use tangent inverse on both of them because opposite and adjacent was there for both of them. If you got a hypotenuse, then it might be a little bit different fractions. All right, so let's look at another example. This time we have B is 2, and we have C is 4, and we're going to find A first with Pythagorean theorem. A squared plus B squared equals C squared. So 2 squared and 4 squared is going to give me A squared equals 16 minus 4, which is 12. And the square root of 12 trees into 4 times 3, or 2 square roots of 3. So this is what I was talking about earlier. You want that to be exact. So this is 2 square roots of 3. Now, I'm not going to label that on my picture over here for right now, because what if I did that math wrong, and then I place everything else in my picture based on that? I would know I would have a real big problem. So I can write in my 90-degree angle for gamma, but I've got to find alpha and beta. So first I'm going to try to find alpha because it's on the horizontal. It's adjacent to B, and it's the hypotenuse for C. So the trig function on some old hippie called another hippie tripping on acid tells me that I'm going to use cosine this time because I have adjacent and hypotenuse. So the cosine of alpha is equal to 2 over 4. We're going to inverse cosine both sides. And we don't even have to reduce that unless you just want to, because the calculator could care less if it's reduced. I mean, this is a calculator active lesson, so use it to your advantage. Well, the board will give me 60. Okay. Now that's a nice number. So alpha is 60. Now we know that beta has to be 30, but let's calculate it to see. So I want to relabel my picture now, and beta from that corner, B is not adjacent, B is opposite it, and hypotenuse is still the hypotenuse. So to work with beta, we would have to use sine because it's opposite the hypotenuse. So the sine of beta is equal to 2 over 4. And if you inverse it, then beta is going to come out to be 30 degrees. Now, if you don't believe me on that, we'll go type that on the calculator, because we know that's what it's going to come out to be. Inverse sine 2 divided by 4 parentheses. And it's 30 degrees. So, from these two examples, let's recap something real quick. If you're using tangent, then tangent of alpha being a at 5 over 12 tells me that tangent of beta is going to be the reciprocal. Does everybody understand that tangent is a reciprocal from either corner? And then for cosine and sine, if the cosine of one angle's fraction is the sine of the different angle with that same fraction, because the relationship of opposite and adjacent have the same fraction from the two different corners. So that's kind of speeds up the process a little bit, because once I work the first one, I know I either do the reciprocal with tangent of the other variable, or I do sine with the same answer for my fraction. So let's look at this one. So in this question, I have A is 1, I don't know B, and I know C is the square root of 5. So that's going to be B squared equals 5 minus 1, B squared equals 4, so B is equal to 2. So we got a really nice answer for B, but I'm not going to put it on my picture. I am going to label my picture with just the A and the C, because I want all my answers to be based on using the original numbers they gave me in case I make a math error. Now I know that gamma is 90 degrees. So A is across from alpha, so this is opposite, and C is the hypotenuse. And we just discussed in the last question that sine is opposite over hypotenuse. So the sine of alpha is equal to 1 over the square root of 5, which means the cosine of beta is equal to 1 over the square root of 5. Because the sine of one angle that's acute in our triangle is the cosine of that same the other angle. Let me start that over. The sine of one angle's ratio is the same ratio of the cosine of the other angle. And for tangent, it's the reciprocal. So that saves a little bit of time on setting it up. Then you can just go and inverse it. For example, I can inverse sine 1 divided by the square root of 5. Well, I don't need that parentheses. I keep forgetting I've got math print turned on. I need it on the outside. And that came out to be 27 if you round that off. Then if I second enter that back up, I just have to come over here to the beginning and do second cosine, enter. So that was 27 and 63. 27 degrees, 63 degrees. So now what you're going to do is you're going to go to the problems in the book on the page that's in Canvas, and you're going to do the first set of questions. I think it's like 2 through 10 even. You've got 5 questions. They are not labeled A, B, and C or alpha, beta, and gamma. They drew a theta in the corner, but you need to relabel the picture the same way I've showed you, that the base is always at the bottom is B, and go from there, because that will help you to label your problem. So you need to stop the video and do that set before continuing. All right, so let's continue. So in our last part of our lesson, you had 2 sides given, and you could find the third side with Pythagorean theorem, and then you use trig to help you find your angles. In this lesson, we only have 1 side given, so we're going to have to focus more on trig and less on using Pythagorean theorem. In fact, I'm not going to allow you to use Pythagorean theorem at all if we can help it, because I think that that's something you might want to stay away from. But I might have to use it on some of them. It sometimes depends on what you're working with, on where you can go with it. So to begin with, let's draw our picture. Always draw your right triangles drawn the same way. Makes it easier if you're having to label the picture yourself, and then this set, the pictures aren't pre-drawn, so you don't know which way it's turned or anything. But you want to always have your right angle in the same corner, because that's gamma. And C is always across from gamma. Now B is the base, so beta is across from that. So B in this problem tells me that beta is 40 degrees up here in the corner at the top. And A in this problem is 6, but I don't know alpha. So there's where we're at, and we have to start with the angle they gave us. So that angle is adjacent to 6, to 40 and 6 are adjacent to each other. So I have to use all the trig that helps me to get adjacent. I also know that gamma here is 90 degrees. And so I can fill that in because this lesson's all about right triangles. Now in our next lessons we won't have right triangles, and we'll have to work harder to find more information. So the first thing I guess I should try to do is figure out which trig function can I use. Some old hippie called another hippie, that has adjacent, tripping on acid. And that means that has adjacent. So I can use those adjacents to help me to find the other sides. So the cosine of 40 degrees is equal to adjacent over hypotenuse, which is 6 over C. Let's solve this one for C, and then we'll look at the tangent example of how to use adjacent in it. Now I talked about this yesterday in the class, how that you switch the diagonal. C equals 6 over cosine of 40 degrees is how you solve when the variable on the bottom is missing. So I go to my calculator and I type that in. 6 divided by cosine of 40. And that's why you want to turn degrees on. That way you don't have to go get a degree mark every time. And that is 7.8. And that is a rounded off answer, unfortunately. 7.8. Now let's use the other trig function, tangent. Tangent at 40 is equal to opposite B over adjacent 6. In this problem, the B is missing on the top, so therefore I can cross multiply. So I switched the diagonal in this one, and in this one I put a 1 under it and I cross multiply, and that looks like I'm doing the same thing on both of these, so I might just take that symbol off and go like this for switch. So this will be B equals 6 tangent of 40. So let's look at that. So 6 tangent of 40 comes out to be 5.0. 5.0, and yes, you do have to write that O because side measurements are rounded to 1 decimal place and angles to whole numbers. So now let's look at, is there any way I can get the angle from the other corner? Well, the problem is if I use sine, for example, opposite and hypotenuse, those two measurements in this question, the opposite and hypotenuse, are 2 decimals I just calculated. If I had stored those values, then I could use them to help me find my answers. But I didn't think of that. Maybe I should do that. So let's go back. So I can store that value right now. That was the one that we were finding for B, so I'm going to say alpha B. And then the other value, I can second enter that back up because we were finding C. And I can store that in alpha C because they gave me A originally. Now I can do it. Let me explain why. So to find your angle, you would have to use sine of beta equals opposite, which is B, over hypotenuse, which is C. And then you would inverse both sides. So beta is found by inversing. -1 means inverse, B over C. And since we just stored those in B and C, we now can use that whole decimal. So sine B alpha B divided by alpha C, parentheses, equals 40. Now let's see if that makes sense. Yes, it does. Makes sense for B. All right, so that's going to work to give me a check to make. That's your check. That's how you know that your 5.0 and your 7.8 are correct, because it is based on the angle 40 came out to be what I got. It's telling me that I've got those two numbers right. Now that I know that's right, that's my check, I can do cosine of alpha with B over C, and that will tell me if the 50 that I get up there is right, because we know it's 50. 50 and 40 make 90. But let's see. So in that case, if I go to my calculator and I do inverse cosine of alpha C divided by alpha B, no, excuse me, I wasn't supposed to flip them. That's tangent. Alpha B divided by alpha, well, what in the world? Let me try again. Okay. Alpha B divided by alpha C. We do the same. I tell you what, this thing's got a mind of its own this afternoon. Let's try again. Divided by alpha C. All right, so what you do is, if it's sine, you just inverse and it gives you the other angle. And as you can see, I got 50. So first I did the one angle that I could get from the corner I was already working with. Then I chose the word cosine because that's the opposite of sine, and the angle fraction stays the same. And that helps you to check everything you've done instead of just subtracting it from 90. You won't know if your decimals are right unless you check things. All right, so now let's go on to a second example. So we have to draw our own picture every time. And again, I always like to draw it from the same corner. B is always down on the bottom. A is always the other leg. C is always this one. Gamma is the angle across from C. Alpha is the one across from A. And beta is the one across from B. They gave me beta again, but this time they gave me side B and not side A. So that's going to change how we deal with the problem. And I still know it's a right angle, so I know alpha is 80, but we're going to use our trig to make sure all our math is right to figure that out. So compared to beta, this is your opposite side. This is your adjacent, and C is your hypotenuse still. So let's start looking at some old hippie, caught another hippie, tripping on acid. This time we're going to use sine and tangent to help us from beta, because sine and tangent have opposite in it. And that's the side they gave me. So the sine of 10 degrees is equal to opposite 4 over hypotenuse C. Now when the letter is missing on the bottom, you switch the diagonal, and that allows you to solve your ratio quickly. You go to your calculator and you type 4 divided by sine of 10. I got 23.0. I'm going to store that. What was I finding? I am finding C. Whoop. I am finding C, so I'm going to store that in alpha C. All right, now we're going to go back and write that answer down. 23.0. It's not exactly 23, so I can't just drop that O. It had a decimal that I rounded it off to. You have to keep that 0. Now let's do tangent. Tangent of 10 equals opposite 4 over adjacent A. And we solve this one the same way. We switch the diagonal. It'll be 10 over tangent of, 4 over the tangent of 10. So I go back and I say 4 divided by tangent of 10. That rounds off to 22.7, stored in alpha A. Okay, let's write that answer down. 22.7. And now we're going to look at doing cosine from beta. The cosine of 10 is adjacent A over hypotenuse C. So if we've done this right, hold on. I should write B here. If we've done this right, we should be able to inverse cosine that fraction and get 10, the answer, to know that our math is right. So let's do that. Inverse cosine, I forgot what letters it was, A divided by C. Alpha A divided by alpha C. Yes, we got 10. So now we know our decimals have been stored correctly. Now we can do sine of that and get the other angle. Inverse sine of alpha divided by C. And that tells us that 80 is correct. So once we realize that we can inverse this, and it comes out to be 10, and we know that's right, then we can do sine of alpha equals A over C and inverse that on our calculator to get our 80, to make sure our 80 is correct. So some of what I'm showing you here on this last little part, the more important thing to do is to be able to do this sine and tangent, because that gives you your side measurements. Granted, I know we could get that angle from subtracting 10 from 90, but you won't know if your side measurements are right unless you do some trig here with trying to see what the angle would be. So that's why I did that beta thing with the picture the way I drew it, and then I switched it to the alpha for the same ratio, because that would give me the 80, and then I'd know for sure I had it all right. All right, we have one more to go. So in this problem, we're going to draw a right triangle again and label it. B stands for the base, A stands for the other leg, C stands for the hypotenuse. The right angle is always gamma, so we can go ahead and fill gamma in. It's 90. We know that C is 9, is the hypotenuse, so we know this time we have to use sine and cosine because they're the only ones with hypotenuse in it. Beta is up here and alpha is over here. So our beta this time, well, I don't know why every time I gave y'all beta. I'm sorry, y'all. It is not really good to do that every time. So I tell you what I'm going to do is I'm going to move that 20 up and just put it in for alpha, because I can do that before I start my problem. and that way you'll have one that had alpha, because this one had beta and this one had beta, and I'd like one at least to do alpha. All right, so let's talk about sine. Sine of alpha, being 20 degrees, is equal to opposite over hypotenuse. So that's A over 9, because A is the opposite side and C is your 9. So that's a cross multiply problem. A equals 9 sine of 20. Now we're going to store that in A. So sine of 20, I forgot to do the 9. I can insert it. 9 times sine of 20 is 3.1, stored in alpha A. All right, let's write that answer down. 3.1 is a rounded off answer. That's why we're storing it, because if you round it off and then use it for a math calculation, you won't get the right answer for the angle. Now, alpha is also adjacent to B. So we're going to use cosine of 20 is equal to B over 9, because this is adjacent over hypotenuse. Again, we cross multiply and get 9 cosine of 20 equals B. So now we can go into our problem and go 9 cosine of 20. Usually whatever you do for sine, you do the same thing for cosine. That's 8.5, stored in alpha B. So 8.5. Now let's talk about tangent. Tangent's going to be our check. So the tangent of alpha should be equal to the opposite A over the adjacent B. So instead of filling alpha in, we're going to inverse tangent this. We're going to say tangent's equal to the alpha is equal to the tangent of A over B to see if it comes out to be 20. If it does, then we can get beta really quickly. So inverse tangent of alpha divided by beta. And it came out 20. So now we know that's right. Now to get your other answer, when you inverse your tangent, you flip the fraction, which is alpha B divided by alpha A. Oh, it didn't take my second key, so let me try that again. Alpha B divided by alpha A. There we go. So when you do sine and cosine, the fraction doesn't change, the word changes. But when you do tangent, you flip the fraction. And that tells me that the other one is 70. And now I know for sure that I've got that right, because tangent of beta is equal to B over A. So this is how you can work with right triangles and only have one side given, and can't use Pythagorean theorem. These are rounded off answers. So you got to use trig, and everything you do with trig, you want to make sure that you're keeping up with every number. And so that's why I kept doing the angles at the end. I did it two ways to make sure I was getting the same answer. Really, to be honest, the only thing I had to do was tangent of beta. But I thought it would be easier to do tangent of alpha since I had labeled the picture for alpha. Once I got that set up, I can convert that to tangent of beta by flipping the fraction. Or, like I did over here with cosine. Cosine of beta was C over A. The fraction doesn't change, but sine of alpha is that same fraction. So that gives you an opportunity to convert it to that fraction and make sure you're getting your answer correct. All right, so you now have a set of questions that none of the pictures are drawn for you. I think it's like 22 through 34 or something like that in Canvas that you can now go through and do this kind of math. And this will be due on Monday.